right. People in the back, you are late, so you should be hurrying. No, come back. Yeah, do what you want. All right. Okay. I think please find a seat. I think I'm gonna start. This is a meme that Professor Carrick made. I noticed this. Anyways, so okay, all right. So yeah, so a little bit more seriously about the midterm in ESC180. So there is an announcement on Piazza with kind of all the details. So the average was pretty high, about 88 out of 100, and that's fine. Like some people come in with more experience, stuff like that. So naturally people are going to do well on the midterm. As we go on with the material, I think the material that we started on the Friday before the break is probably new to most people. So, it's going to be a little bit different, I think, going forward. Hopefully, people also kind of, and I see that in the midterm as well, kind of people learned. So hopefully, we will have kind of a more even playing field, as it were, going forward. But of course, everyone just tries their best. That's what it is. So because it was high, so people requested the histogram. So the histogram looks like this. So that's also on Piazza. That's what it would look like with this kind of average. So people naturally also asked whether that means that, like, there would be a curve down or something, or if the exam is going to be more difficult. The answer is just no. So I like to point this out because people don't know, but U of T actually has a policy about this. And the policy, I do want to share, because that's official policy. So the policy is you're not supposed to curve at all. People don't know, but it is the policy. So what it means in practice in ESC180 is kind of what I said, like the exam is going to be the usual exam. Now, what also happens usually in ESC180 is the exam is kind of difficult. And then what I do is I adjust the exam grades up, sometimes by just adding a constant number of points for everyone. Naturally, that just mathematically means, yeah, you can take it. It's on the website. It's not going away. So naturally, adding points to the exam is the same as just adding points to the course marks. And naturally, when I do that, I also consider, okay, what would be a reasonable thing to do in terms of how many points to add. I don't always do that, but sometimes I do. And, I might add fewer points just because, I will give you like fewer free points, maybe, if the exam is kind of depending on the difficulty of the exam. I'm not going to curve down or anything like that. I'm not going to intentionally make the exam more difficult. If you want to see what the exams are like, just look at the past exams. It's not going to be that different. So there was kind of a particular story was that I did, at the last minute, I just decided I wanted a shorter midterm and I didn't see a point in adding the last question, but people asked what the last question was that got taken out. This is the question. It's on Piazza. You can take a look. You should, in fact, go and practice with it because, people asked for it. I thought about just like saving it for the final exam, save me some work, but people asked for the last question. Here's the last question. It's not going to be literally on the exam, but something like it might show up. Who knows? Okay. All right, so that is what I have to say about the midterm, other than just saying, a high average. Yes, I took out one question, but all the others were well done. So good job, everyone. Yeah. Unlike in calc from what I hear. So, okay. All right. Questions? I don't really have much more to say, but if you have questions, I'm happy to answer, like either here or on Discord or whatever. What are people saying on Discord? When is calc out? I have no idea. Ask Professor Davis. So okay. I just I did happen to speak to him earlier today, but he didn't say. Anyway. All right. So that's what I have to say about that. So life goes on. So in particular, you're doing hopefully project 2. How many people have started project 2? Okay, that is actually great. So I want to talk a little bit about debugging infinite loops because that does sometimes come up as you go further into the semester. So I think that's the appropriate time to talk about it. And then we'll go back to talking about the Python memory model. We're going to be talking about it, for a little while. So, okay, infinite loops. So as you remember, an infinite loop is something like that, right? So I might just make a mistake. For example, I'll make a function. I'll call it like counter. And that's supposed to print 0 up to n. Of course, usually I would do it with a for loop, but let's say that I want to do it with a while loop. And I'll intentionally try to make it an infinite loop. Okay. So I'll say, I is equal to 0. Then I'll say while I is smaller or equal to n, because I want to include n, so smaller or equal, right? And I'll say print I. Make sense? It shouldn't make sense. I made a mistake intentionally. Okay. So what's the problem here? Anyone? Yeah. Yeah, it's just gonna keep printing 0 forever because I forgot to say I plus equals 1. Right. But let's say that I didn't notice. And I call it. And I want to count to, I don't know, like how much did you get in calculus? 23. So okay, that's like even worse. Okay. So what can I do? So what am I gonna do here is I'm gonna say, okay, like here I can tell by I what's going on. I'm just doing an example. So what I want to do and what I can do in Paizo is interrupt the execution of the program and drop into where I stop. So the way I interrupt is I press Control I. And that stops the execution of the program. So Control I, like so. And then what I'm able to do is do what's called post-mortem debugging. So I can drop into where the execution stopped. So it's like somewhere deep in the stack. Sometimes it happens, but I can go. So I press the stack. So this is like a function calling a function calling a function. So here, the call happened here. So I interrupted while it was printing the next 0. Make sense? So I am now on line 7 at the point where I interrupted. So I can query what's I. And hopefully at that point, what I'll realize is, okay, I is 0. What's going on? It was supposed to get incremented, but it wasn't. So at this point, I'll hopefully realize that I should have said I plus equals 1. Make sense? So I'll stop. So this is the small red cross here. And I can run it again. And now it's fine. So it counted from 0 up to 23. Questions so far? So another thing that could happen is like maybe I forgot the condition. So maybe instead of, well, that's kind of a silly thing, but like let's say that I just said like while true instead of while I smaller equal to n. A weird thing, but could happen. So how could it happen? Well, like maybe I made like a typo and maybe there is like an I that's also equal to 0. And then I'm saying like while I is smaller equal to n, and that's always true. Make sense? So that's another kind of infinite loop where I am going to be incrementing, but I, which is still 0, is always going to stay 0. So I'm calling it like that, and now it's counting to infinity. Right? So again, I can interrupt. I can say postmortem. So again, like the reason it's calling a lot of functions is it's called print and then print code something. It was in the process of printing the next thing. So at this point, I can again say what is I, whatever, 8,000 something. So that makes sense. And then what I'll do is like, if it's an infinite loop, like probably I need to check the condition. So at this point, what I'm doing is I'm highlighting II smaller or equal to n, Alt Enter to run that. I can also just type it in here, right? And then I can say, okay, like that's true. So that makes sense because I'm in the while loop. So it must have been true. So then I can, again, query, well, what is II? What is n? And hopefully at that point, I realize, oh, like I was checking the wrong thing. Make sense? Yeah.
How could this happen with the for loop?
So the question was, how can this happen with a for loop? I wasn't gonna do this because it can happen with a for loop, but it would have to be pretty exotic. So actually, one of the lessons here is do not use while loops unless you really have to, because as you imply, with a for loop, ordinarily it just wouldn't happen, right? So if you say counter 4, and you start with a for loop, well, like it has to, like you're saying, like for I in range, n+1 or whatever, well, like it would have to be print I. And it would, like, how could it be anything else, right? Yeah.
Like, I guess it's different from like Java, for example. You can do it.
Yeah. So I'll tell you how to do it in Python, but it's not straightforward. So yes, like what's going on here is you're saying for I in range n+1, and what that means, by the way, is this is an interesting example, though it's like a little bit exotic. So here, this means that I is what you would think it is if you don't think too much about it. It's going to be 0, 1, 2, 3, and so on. You might ask, well, isn't I plus equals 1 changing I? The answer is yes, but it gets set right back to what it was supposed to be at the next iteration. So if you print I over here, so according to what I said, what would the output be? Anyone? Yeah. No, not 0, 0. The guesses? Yeah. Yeah, so initially 0, 1. Yeah. So what it would do is initially I is 0. And then I becomes 1. Because you're saying I plus equals 1, so I becomes 1. But what 4 does is it sets I to 0, then 1, then 2, then 3, and so on. So that means that I is going to be 1 again, and then I is going to be 2. And then I is going to be 2 again, and then I is going to be 3, and so on. Up until the point where I is equal to n, and then I is equal to n+1, and then you're done. So the I is equal to n+1 is this guy. Okay, does this make sense to everyone? Questions about this? Yeah.
Or is actually like resetting I for what the next.
Yes. So not so much resetting as like setting. Like the job of for I in range n+1 is to say make I 0, then make I 1, then make I 2, and so on. You can change I in the middle. That's fine. It's just gonna, when it goes to the next iteration, it's gonna set it to the next thing it's supposed to be. Yeah.
So to make for loop implemented, it's possible to change n?
No. No, that is not possible. The question was, can you change n? And the answer is, well, you can change n, but the range n+1 only gets computed once. So whatever you put in there gets baked in.
Oh, so for loop doesn't go through range.
Yeah, it's not a while loop that's like checking every time. Range n+1 basically creates the ones, an object that's like 0, 1, 2, and so on up to n. And then that object you cannot really change. All right, so you can change n, but range n+1 already baked the cake, essentially. All right. So the question was, how do you, okay. I'm going to, so that would take a kind of 5 minutes. So if you don't mind, I'll answer your question on Wednesday because I got to move on. But it's an interesting question. If you want, like, also you can just Google it. If you want to try to do it in a problem solving kind of way, the hint would be you want to iterate through a list, but you want to be modifying the list while you're iterating through it so that you keep adding elements, essentially. So I'll show you on Wednesday. All right. So that's like this. So the lesson is use a for loop that's very difficult to make. It's very difficult to make an infinite loop with it. It would take me 5 minutes, which I don't have. There is not really a reason to use while loops in project 2, except if you want to practice debugging infinite loops, which might be a roundabout way of doing that. If you encounter an infinite loop, do something like that. We'll also make you practice it in the lab on Wednesday. All right? Yeah.
Is there a way to do something similar in VS?
Yes, there is. So we're going to switch to VS Code in like a week and a half. The reason I start with Piezo is that Piezo is less brittle than VS Code. So like VS Code breaks in all sorts of fancy ways quite often, and I do not wish to try to help every person who starts programming with VS Code. That would not be a good time. So I'm doing Piezo, which does have kind of disadvantages, of course, but it's like more stable than VS Code. And then once people are comfortable with Piezo and they know that they can do this, then we can switch to VS Code. Hopefully that will, I mean, VS Code does have advantages, but I really do want to make people kind of know that you can do that. And most people don't, unfortunately, and this saves a lot of time. All right, cool. Questions? All right. So, okay, so what I want to do now is go back to the Python memory model. So I want to point out that we do have notes for the Python memory model, so linked from over here. So that's kind of a PDF I made that's kind of, I don't know, 7 pages, so not very much, that you can just read. I'm going to do a lecture that basically goes through those notes, but it's a little bit different because you already have the notes anyways. All right. So, okay. So what I want to do now is talk about the ID function. So if you remember, what we have in Python is we have a memory table and we have a variable table. And then if you say, so this document, by the way, you can just copy it from over here if you like. So what I'll do is I'll just copy and paste my memory table and my variable table into a new document, and you can just use this one as the template. Make sense? So copying this, making a new one. So if my code is like this, so I say x is equal to high, what happens? So high is somewhere in memory. So for example, here. And then x equals to high. So once high is in the memory table somewhere, I can say x is at 1120, for example. Make sense? And then when I say, print x or whatever, Python is going to go to 1120. It's going to find the high and it's going to print it. So I can actually find out almost, I would say, where things are in Python. So almost, because it's not like completely real, but it's like almost real in terms of where things are in the hardware. So I can say x is equal to high, and then I can ask what is the ID of x. So ID is a function that basically returns the address where the data that corresponds to x is stored. So the answer is over here. Okay. Obviously, that's going to be different between different runs, because, you know, Python just decides on the fly where to store the string high. This address might not be available the next time you run it. Yes.
You say X equals high in the beginning. Is it creating like the value high or like the string of characters, and then it'll allocate it to an address, and then it allocates X to an address at that point? Yeah.
Yeah. So essentially what you said is a little bit of a fairy tale, but the lesson is correct. So it's not exactly, so what you said is high gets stored in memory, and then the address where high is gets assigned to X. And the answer is yes, like think about it like that. It's not quite right. This is why I say it's like a little bit of a fairy tale with the correct lesson, because Python might try to optimize. So if I say y is equal to high over here, and then I say print ID y, that's going to be like that. It doesn't have to be like that. But if I run the program, ordinarily it would be. So what happened is on line 6, it wasn't the case that high was placed into memory, because Python was smart enough to say, oh, actually, like that string was defined elsewhere, so I'll just reuse it. Make sense? But the moral of what you said is correct. Like you can think about it, and this is how I'm going to lecture as well, is every time you have something on the right-hand side that puts it into memory, and then the address of where it was put into memory gets placed in the variable table into the variable. Make sense? So few exceptions where Python tries to be smart. Yeah. Will high always have the same address? No, it won't. So this is getting a little bit into the weeds. I'm not going to test you on the answer, but here's something that you might do. So you might say Z is equal to input, give me a string. And then I'm going to print ID Z. Make sense? So, okay, so X and Y have the same address. And what I'm going to do is this, and that is a different one. All right. And that is because Python, like, what would it have to do in order to say, oh, like Z is actually high, so it's fine. I'm going to say Z is also, you know, 1317518. Yeah. Okay. It would have to check every existing string and say, does it happen to be equal to high? So that would not be efficient. However, Python does not guarantee either way what it will do. The reason it's okay to play those games with for Python is that you cannot go and change the contents of X, Y, and Z anyways. Those are immutable values. So that means that even though X and Y are aliases, there's not going to be a problem. Does that make sense? So X and Y are aliases. Right? So you cannot go X at 0 is equal to capital H. That's not the thing. Right? So I try to run it, and that will just crash. You're not allowed to do something like that, unlike with lists. So the reason this is important is that if it were the case that you could do it, then that would be a disaster, right? Because you're changing the value of X, and magically Y changes as well, even though you didn't intend for it to change. But strings are immutable, so it's fine. Yeah.
So you said like for the input, if you put the same string, then you have to check every one. But when you do Y is high, is it also checking every single string, or how would it?
It is. So that's a great question. I was a little bit glib. So the question was like, well, like if I said that you cannot check every string, then isn't that a problem for X and Y? And the answer is, well, it's checking every string, not in memory, which would be difficult because potentially you have a lot of stuff in memory. It's checking every string in the program. The program is written by a person, so it can't be that much. Right. And there is an efficient way of doing that as well. So it's not like you don't even have to check every string. We'll talk about that at 190. Like there is a technique to do it really fast on average. Yeah.
Is it like the difference between like a runtime and compilation?
So the question was, is it a difference between kind of doing, so there's not compilation in Python, right? But it's a little bit that, so it's a little bit of a difference between doing things while the program is running versus doing things just before it's running. And it's true that that's a part of it, but the main thing is that, you know, so those are called literals, if you remember. So like there's not very many literals in the text of the program because the program, a human wrote it. So it's not as big a deal. On the other hand, in memory can take gigabytes and gigabytes, right? So that would be harder. Does that make sense? Questions? So that was an answer to a question that was asked, not really on the test for 180, might be on the test for 190, where we cover it in more detail. All right. So, okay. So we were here. So this is what is happening. ID gives you the actual address where the thing happens to be stored. We make up addresses for the memory table. This is annoying to type. Right. So that's ID. So to remind you, the reason you might look at this is like actual aliases, right? So if you say something like L1 is 567, and then you say L2 is equal to L1, Control R to comment things out. And then if I print IDL1 and I print IDL2, those are the same. And unlike with strings, this is concerning, right? The reason this is concerning is if I go L1 at 0 is equal to 7, what does Python do? It goes to this address where both L1 and L2 live. L1 and L2 are aliases. They are different names for the same thing, the list that lives at this address. And it changes the first element of the list that lives at this address. L1 and L2 both refer to it. They're the name for this same thing. So that means that if you print L1 and L2 here, this is what you get. So both L1 and L2 have changed because L1 and L2 are aliases. So let's do it in the memory table. So we said, so this is the code. I'm just going to copy it over to my document. So what's happening here? So deleting the height. So there's going to be a slight subtlety that we'll see later on. But for now, I'll just write like 567 somewhere. So once 567 are all in memory, I can create the list L1. So that would be at 1056, at, oh my God, at 1088, at, I'll figure out a way to turn this off at some point, at 1120. Once I've created this list, I can say, okay, L1 in the variable table is going to be 1152. Scroll down. This is old stuff. That's not there anymore. So I'm saying L1 is going to be 1152. When I say L2 is equal to L1, this is not changing the memory table. This is saying L2 is also at 1152. So when I say print ID L1, if you want to be really persnickety about it, you would say, well, IDL1 and IDL2 should be placed somewhere in the memory table. That is true. I'm just not going to do it. So IDL1, what is it going to be? It's going to be 1152. And this is going to be 1152. Actually, why don't I do it? So if you have to make this value 1152, it has to be somewhere. For example, here, just a value, because if you're printing it, it must be somewhere in memory. But there's no variable that refers to it, so you cannot access 1152 after you've printed it. Make sense? Yeah.
So instead of L2 also referring to 1152, it's actually referring to another address, which refers to 1152, which then refers to the actual.
No, like L1 and L2 are both 1152.
Why did they need a separate address?
No, it just needs, like, if I'm saying print this, well, it must be that I'm printing some value, so it must exist somewhere in memory, for at least for the duration of the run of the print. Yeah. Because like you're printing a value, it must be somewhere in memory. Okay, but there's no variable that's referring to it, so it might be gone at this point. So when I say L1 at 0, sorry guys, quiet down a little bit. Sorry. Yeah, so sorry, guys. Yeah, so I have, there's kind of various people have different levels of tolerance for noise, and having been to the dinner dance multiple times, I know that most anxiety have a very high tolerance for noise, but my tolerance for noise, unfortunately, is quite low. I get distracted if people talk. And there's other people in the audience who are like that as well, so out of respect for them as well. All right. Okay. So when we say L1 at 0 is equal to 7, what does it mean? Well, L1 is the list that lives in 1152. And we're saying take the address of 7, so 1120, and put it in here. So that means that this becomes 1120. And naturally, if you print both L1 and L2, well, L1 and L2 are both this list. So this is now going to be 767. Both times. So that's what it means for L1 and L2 to be aliases. Make sense? So, okay. So now that we've done it, so I do want to do something that's a little bit fun for a short while. So what I'll do is I'll say for I in range -10, type along with me, 260. So I'm going to print I, and I'm going to print ID of I. And I'm going to look at what that looks like. Cool. So, and that's, again, not guaranteed to happen, but in practice, that will happen. This is how, like, all of the versions of Python that anyone uses work. So values from -5 to 256 happen to be pre-stored. And the way you can see it is they are stored at intervals of 32. So this is this plus 32. So conveniently, this started with 0, 0, 0. So you can see that it's plus 32. And this is also plus 32, also plus 32, also plus 32, and so on. And that goes on up until here, at which point 257 is not pre-stored. So while we're at it, here's another fun thing that you'll notice again, not guaranteed to happen, but will happen in most computers, those alternate. So similarly, if you look at -10, -9, and so on, also alternate. Does anyone have an explanation for what's going on? Why do those addresses alternate? There is like a logical explanation for why you might expect this. Anyone? Yeah.
My guess is that it doesn't want to waste memory on so many numbers.
Yeah. Yeah, exactly. So when you're saying print -10, what happens? -10 gets put into memory. Okay, because like I was -10, so it must have been put into memory. Then it prints it, but then it says, I don't have access to -10 anymore. I is now -9 anyways. So I might just reuse it later on. What happens in practice is this memory slot does get reused. So it used to store -10, and then there was no variable that was referring to this address. So there was no point in keeping it. So the same slot got overwritten with -8. It does it, but not right away. You should not be relying on this behavior or anything, but it's interesting to notice that it happens. Does that make sense? Questions? Yeah.
Why did it stop alternating?
So it stops alternating because -5 up to 256 are actually pre-stored. So what happens is when Python starts up, it pre-stores -5 to 256. So those are always pre-stored, and they're pre-stored like ordinarily in addresses with an interval of 13. Yeah. I mean, like nothing is guaranteed, right? And like it's just like an interesting thing to notice that it would reuse memory slots if, -10 is no longer referred to by any variable. But like always, well, kind of like if you make it like that, then yes, but it's depending on the situation. You should not be relying on this behavior. It's just like interesting to know that it's there. Okay. Yeah. Yeah.
It's something that we see only in though. Is it extend to Python?
No, I mean, like there is like a JPython, which I'm not sure it does that, but any implementation of CPython, you're supposed to see that. Yeah. I'm hoping you're not asking because you don't see that. Yeah. But yes, like ordinarily that would happen. Yeah. All right. Yeah. So -5 to 256 are preset. So when Python starts up, it actually pre-stores all the numbers from -5 to 256 in intervals of 32. -10 is not preset. So -10 is stored on the fly. Yeah. I mean, there is no, so always mean like in practice, any Python that you would use, yes, that would happen. In principle, on different hardware, different versions of Python could be different. Okay. All right, other questions? Okay. So, all right. So I was hoping that we'll get to it, and we did. So the rules are actually very simple in terms of what happens when you do an assignment. So if you have LHS equals RHS, so by LHS, I mean left-hand side, RHS right-hand side. Basically, if RHS is a new object, you place it in memory. There are a few exceptions like we've seen. Don't mind them. Just think about the fairy tale version where if the RHS is a new thing, it gets placed in memory. What then happens is take the address of RHS and place it to LHS. Right? Two situations. If LHS is the name of a variable, that must mean that you're going to the memory table. So this is the situation, with L2, L1. So if the left-hand side is L2, then it must mean that what you do is you just go to the variable table and you say, I'm copying the address where L1 lives to L2 as well. So just copy this over here. Importantly, that means that you're not modifying the memory table, just the variable table. On the other hand, if LHS is an element of a list or a dictionary, then again, you're still just copying the address of RHS, but you're copying it into the memory table. So that is the situation over here when you're saying L1 at 0 equals 7. So what we did is we copied the address where 7 lives over here. Importantly, that means that if what you have on the left-hand side is an element of a list or a dictionary, then this operation goes into the memory table and messes with the memory table. So potentially there would be aliasing problems because it might be that the location in the memory table that you're changing, there's several variables that refer to it because they're aliases of each other. That is basically it up to now. Okay, so the rules are actually very simple. Yes.
If LHS is or one of them, if it's a tuple, does the same thing apply to the variable?
So that is it is true that LHS can look like a tuple. It's not actually a tuple. Like there is no situation where it's a tuple. So what you are referring to is something like this, right? This looks like the left-hand side is a tuple. It is not. It's just a way to do multiple assignments. So this is equivalent essentially to A equals 1, B equals 2, C equals 3 simultaneously. And the reason I was kind of persnickety about it is like it's not a tuple. So what's on the right-hand side is a tuple, but it gets unpacked. I do not know how to spell simultaneously. Something like this. It's 5:59. Give me a break. Okay, all right. And speaking of which, it's now 6. I will see you on Wednesday. See ya. Bye.